Okay. Hi everyone. This is welcome to my class mth 5106 for master and PhD program in mathematics. This lecture is about integral equation. Okay. On integral equation, where we will cover all type of integral equation. So as an introduction, so the integration actually appears in many sort of application. For example, if you work on the fracture mechanic, wave, for example, water wave, diffraction of light, of wave also. So there appear in many application. So generally speaking, the integral equation, we define the integral equation as in which the unknown function involve the integration. Yeah. So for example, in this case here, so we have the unknown function inside the integral. So this is, we call it as a integral equation. So in this case, f is known function, and this is the unknown function. And the limit of integration can be variable, can also be fixed number. So there are many type of integral equation. For example, Freedom integral equation, Volterra integral equation, equation with convolution kernel, the Wiener-Hopf equation, dual equation, integral transform, singular integral equation, non-linear integral equation, and many more. So in the following, we shall assume that all functions are measurable, means finite. Independent variables are real, except when otherwise stated. Known and unknown function can be real or complex. Alright, so let's define the integral equation. So the integral equation is the equation, as I mentioned earlier, that unknown function appears under one or more sign of integration. So they can occur other term as well in integral equation. For example, in the rectangle x between a and b, t between a and b, the following are the integral equation. So this is the first. For example, you have fx integrate 0 to a to b k u dt. So in this case, the unknown function appear in the integral in the integral sign. The second case here, so you have the unknown function where ux and ut, this is an unknown function. F and k are known, so also an integral equation. And for this case, we have the unknown function squared inside the integral. And the last example here, so we have again the multiplication of two functions of s and t. This is also unknown. This is unknown function. K is known function. Okay, so in each of the above equation, ux is unknown function, while fx, k, x, t, and kxst are known function, either real or complex, and ab are the constant. So the integral, that integral 1.1.1 and 1.1.2, that one, can also be put as a the operator form, where L is the operator. So where the expression L is linear in the sense that, so this is, we call it as a linear function. Okay. If we apply the operator L on each of those function with multiply with the constant C1, C2, and Cn, So can also be written separately, C1 LU1 plus C2 LU2 and so. So this relation we call it as a linear linear. Okay. So if the any operator can be written as that, so that operator we call it as a linear operator. So thus, if you refer to that expression, then the integral equation 1.1.1 and 1.1.2, which is this equation here, all right, can be written as in the linear form, in operator form. You can write it as LU, all right. So we have from fx equal to integral a to b kxt ut dt. We can write that as a L u x, which is a to b k xt ut dt. That's equal to fx. You can write that as that. Okay, and for the second example, so we have ux equal to fx plus integrate a to b kxt ut dt. You can write this as a ux minus integrate a to b kxt ut dt. This is equal to fx. So on the left side here, we can define this as a operator, integral operator. Okay, so now note that the integral that we mentioned earlier are all non-singular integral equation and may be further classified into linear and non-linear integral equation. So now we define what is the linear and non-linear integral equation. So the non-linear integral equation of type 115, if you look at the notes 115, so that equation, okay, so which means you can write in either in that form, or that form you can write in the in term of linear operator, where L should be U here. Lux is a linear expression in which Ux appears under one or more sign of integration, is called as a linear integral equation. So in other words, the integration is called linear if only linear operation are performed in it upon the unknown function. So the non-singular integral equation which is not linear is known as non-linear integral equation. So if you look at the this example here, just given in the previous page, so we have, this is a linear integral equation. This is linear integral equation. Why? Because the unknown function only it doesn't involve multiplication of the unknown function, whereas in this case we have squared here. In this case we have multiplication of two unknown function. So both of these are non-linear integral equation, whereas for this is a linear integral equation. Okay, so the function k appearing in equation 111 and 112 is known as the kernel of integral equation defined in the rectangle of xt plane. So the word here is the kernel. So the known terms here, that's k, this is we call it as a kernel of integral equation. The integral equation is completely specified by giving the interval AB, the kernel kxt, and the function f. So if we take f equal to 0 in 112, we obtain the what we call as a homogeneous linear integral equation. So if you consider 1.12, which is this equation here, yeah, and then if you take f 0, then what we have, ux is equal to integrate a to b xt ut dt. So this is, we call it as a homogeneous integral equation. So the difference is that we have for f here we have 0. Okay. Now, when the integral equation 1.11, 1.12 and 1 to 1 is the homogeneous, 1.11 with fx are considered simultaneously, and then the equation 1 to 1 is called the homogeneous integral equation associated with the integral equation 112. And it is also quite convenient to introduce the parameter lambda into the integral equation of the second kind, so which then we have the following form. Yeah, so we have fx, ux the unknown, the fx is known, plus we have lambda, some constant lambda, the integration, and the kernel kxt, and then again we have the unknown function. So the constant lambda can also be incorporated into the kernel of the integral 1.2. However, we can obtain useful information by studying what happens when lambda is allowed to vary in the complex plane. And later we know this lambda as a eigenvalue of the integral equation, but we will study those things later. Now, if the kernel of the integration is 0 for x less than t, so for x less than t, then the integral equation, we have those ux, fx, lambda. The limit of integration here we have from a to x, yeah, k, u, and dt. So in this case, the limit of integration is the variable. The upper limit of the integration is the variable. Instead of the previous one, we have the fixed value. And then we look at the most general type of integral equation. Yeah, the most general type of the integral equation given by that gx, ux, fx, and so for this general type of integral equation, so we have gx ux is equal to, my pen is not good, where is okay, I use red one, is equal to fx plus lambda integrate a to some upper limit, could be a fixed number b or variable x, and then we have the kernel of integration and ut dt. So we say this kind of integral equation as a general because we can choose g. Yeah, you can choose g equal to 0. So what happens if we choose g is equal to 0? So what we have is that fx plus lambda kxt ut dt that equal to 0. This is t. Then this integral equation is known as linear integral equation of the first kind. Yeah, linear integral equation of the first kind. We say linear integral equation of the first kind. Then if you consider g, is equal to 1, yeah, g equal to 1, so what we have, those integral equation become ux equal to fx plus lambda integrate a to some upper limits xt ut dt. Okay, So this kind of integral equation, we call it integral equation, linear integral equation, linear integral equation of the second kind. And the third one, if g is different than 0 and also g is different than 1, then we have the general form here. So this we call it as a linear integral equation of the third kind. Okay, so that's a brief introduction on the definition of integral equation. What is the integral equation, linear integral equation and non-linear integral equation? The linear integral equation of the first kind, of the second kind, of the third kind, as well as I have mentioned the homogeneous and non-homogeneous linear integral equation. Yeah, for the homogeneous linear equation, we have fx is 0. If fx is different than 0, then what we call that as a non-homogeneous linear integral equation. Okay, so with that, I think I stop here for the first lecture. Then I will come up with the second lecture later. All right, so thank you very much. Bye.